Okay, let's start. So today let's discuss about how you can start thinking about creating your own machine learning algorithm or machine learning model, and in companies also how do they take those projects and how do they assign you the work and what is your role and how do you start working on that. Presently, if I want to create my own algorithm and I want my machine learning algorithm to understand and learn from my data that I am giving, and it has to do whatever work I am telling it to that, then what steps I should follow? Okay, so that we need to look at here. That question we will solve it today. All right. So there are many steps available that you can follow, or that is the procedure that you follow to create a machine learning model, right? To understand the data and give you the answers. All right. So those 8 steps will be consecutive steps, means one connected to another. So to feed that previous output to the next step, we call them as pipeline. Okay. So here we have a machine learning pipeline. All right. Yeah. ML pipeline, okay, machine learning pipeline expresses the workflow by providing a systematic way of how to proceed with the machine learning model. So here is the diagram that we have to understand what is happening in the model, and you just need to understand this one as a part of your process that happens when you sit alone and try to create your model. Okay, what are the steps you need to take? So firstly, you need to see, do you have the relevant data which you want to use it in your learning of your algorithm. And before that, you just need to think about what the problem you are trying to solve. Very important. So you need to define the problem that you are trying to solve. For example, you wanted to design an algorithm to decide whether you should go out or you should stay at home. So based on the weather. So what is the problem that you have? You don't know whether the rain will come or not. Okay? And whether the humidity is so much out there or not. Or some problem is there outside. So that I don't know. I cannot predict it. That's why I am taking a help of AI program which will tell me whether I should go out or not. In order to be a generic I am talking about. If you create a device. So that problem I have identified now. Now I should decide and also get to know what are the key parameters which is going to affect my decision making. Alright. That parameter we can call them as KPIs. KPI. You heard of this? Key performance indicators. Key performance indicators. For example, if I ask you, you have a 2-wheeler or 4-wheeler, how do you say how efficient it is? What you start telling, what immediately get in mind, they are your KPIs. When I ask you, is your vehicle is good? When I immediately ask you this question, you start telling something. That something is KPI. Alright? Because you are trying to tell the other person who asks you the question that these are the key points. Based on this thing, this all things will work. Alright? That means you are talking about decision making parameters. Like I tell, my average speed if I maintain it like 60 or 50, my mileage will be this much. So you talk about that mileage. Mileage will become a key performance indicator. That means the performance of a vehicle depends on this key component that we are talking about. Alright. So whenever you have a problem, you are defining for a machine learning model, you have to define this key performance indicator first. Alright. Then you collect the data about some situation or that problem, and along with the key parameters that are available and that you have told, and that must be in the data format, any data format that you have. Okay. Most generally, it's an Excel format. So those columns that you have seen earlier, they are actually not the whole data that a problem is having. They are only the key points that they have listed up. Because based on those things, we can make a decision. So whenever such data is getting collected, we call that kind of data as a data set overall. Alright. So that kind of a data set might be not perfectly available for a machine learning model to be trained. Alright. That means I have collected the data, but some of the fields are empty. Some of the fields are having wrong data. Like in place of number, there is a name written. Alright. So that kind of a data we call in a data language as a dirty data or dirty data set or unclean data set. Alright. So for that, what you need to do, you need to clean the data or you need to prepare the data for the machine learning process. Alright. That is your first step. So what is your initial step? You identify the problem that you want to solve. Alright. Like another problem that we have that is being solved is face authentication. Alright, or face recognition authentication or attendance also for face recognition. So what was the problem? So problem was I wanted to authenticate a person with a face. So now the question comes is what are your KPIs? What is your key performance indicators? So what are the key components on which you decided that this is the person? A lot of persons and everybody is having the same components of the data set. Everybody is having the eyes, two eyes, it is there, nose, it is there, everything is same. So how do you decide that this person is not that person, this person is not that person? How do you differentiate that? That differentiating factor will be your data set. Alright? So that you have to decide after the problem. You decide the KPIs, and after you decide the KPI, you collect the data, and that data is dirty. You clean them, then you are ready with the data that is ready to be fed into the next algorithm for training. Alright? Okay, so that will be done in the data collection and integration. Data collection, I understand. How about integration? You might have heard of the BI tool or Tableau. Heard of it? No? Okay. There's a business intelligence tools are there. They are the machine learning tools. So what do? They connect all your databases, like you have used Firebase and there is a MySQL database and there are a lot of other databases which will become a data source for such tools. I open that software and that software asks me what kind of databases you use from which I can fetch the data and create my data set. Alright? So, for example, you are connecting with the AWS, you are storing all the data on the AWS from this data, and that AWS link will become one of the data sources for my software. You are also storing some of the data in MS SQL. From that, I will copy the link of the database and I will give to my software. And from all the sources of databases, I will put all the links into one software. Okay. In that dashboard, I will be able to analyze and I will be able to create a visual dashboard to all the data sources. Right? When I am going to take all the data sources and gather at a place, that place I will call it as a data lakes. Data lake. I am gathering all the data into one place. That's why I am calling it as a data lake. Right? So in that data lake, from that data lake, you are actually integrating the sources with the software that is actually consuming. Right? So that we are talking about here. Data collection is one thing, and you can collect it from the different data sources. That is integration. Understand that? Okay. So then what you do? You do visualization. You do data visualization. So presently, whatever data you have, that you are going to visualize. How does it look? And then you do analysis on the existing data that you have, right? Whether the data is ready for the further analysis, and also how does the data is spread across. Okay, so you're finding out the mean earlier. You're finding out the mean squared errors. All right, then we have outliers. Okay, so all this initial analysis that you do on the data, whether the data is in a specific format which my algorithm is suitable for, that I'll be doing to decide. And then there is a feature selection and engineering. This is also very important as I'm talking about your APIs. Feature engineering is one of the important part of us as a developer to tell machine learning model that what are the important points that it has to consider to make a decision. Obviously, machine learning has to make a decision. So you are telling them what are my key points on which my decision making is dependent. Earlier, when machine learning is not implemented in companies, what people are doing? People are going to take up a board sheets and they'll be looking at the data and they'll be making a decision. How will they make the decision? They just mark those important points and they collect those important points and they make a decision on those points. Same thing with assigning to the technology. Nothing else we are doing. Alright? So we're just trying to now if the person who is executive engineer in the company to understand the previous year data because he only have done the analysis. Next year when I tell him to do analysis, he will tell last year data I have analyzed, so I understand what is the last year and year. So complete 10 years, for example, if he analyzes, he understands the whole company's scenario. Same thing we wanted to do in 5 minutes with the help of machine learning, not on 10 years. I have the linear data, but I want to replace that person and I want to create a machine learning model in 5 minutes. I want to train this model. So I have to give the same data as I have given to that person who is in the company who is analyzing the data. Same kind of key data I have to give to this algorithm. So I have to select the features from the data. Alright. Then only it is possible to train my model based on a specific features. So those features we are calling as independent variables in our equation. Alright. Our x values are features. So that's what feature engineering means. What is engineering? It is solving the problem. Alright. So in feature engineering, we try to look at the data and we try to point out what are the key features that are available.
So features are the yes variables. Then what are y variables?
Here are the outcomes of those features. What decision making you want to do. You already know what decisions will be done with this data. Because that is my experience data that I am recording. And I already know the answer. That will become my training data and training outcomes. This is my independent variable, dependent variable y. Both of them I will be doing in my supervised learning. So that's why there will be features and y will be your outcomes. Alright. Now model training, and in model training we will be going to define what kind of training has to be done with the help of data. The data that is being stored or being taken up in the feature selection will be given as an independent variable and dependent variable. If it is in what you can say supervised machine learning model. Alright, where we have the labeled data. When I say labeled data, it is question with answers, features with the outcomes, x and y. Both of them are talking about. Alright, that's why I am calling as labeled data. That means I am telling what this meaning is, I am giving the meaning also. What this sentence meaning is, I am also giving the answer. So along with the question, I am also giving the answer ready as a training data. That's why I am calling them as a labeled data set. So that we can do on this one. And once the model gets trained, and whenever I am going to train, what does that mean? Like, is it like a same like our train a human, or teach to the human, or a student? Is it same as we do in classrooms? No, it doesn't happen like that. Okay. It tries to analyze the data. When I say analysis, it is a big word. You may not understand that. As we are trying to find out the difference between numbers earlier, what was the mathematical formula that we were looking at? This is standard deviation. You heard of that? So we were just looking at how the two numbers or three numbers are giving a different values. The fluctuation that is happening in the data between multiple values, that is going to record in its own format called machine learning. It's creating its own model. It's our own understanding of knowledge. It's creating that difference. I mean, it's creating a knowledge base. Right? That pattern or changing the values it is going to record, and if any similar data is there, then it will look for nearby possible values. That's why we are calling them as probable values or predicted values. It is not actual values. You ask me this question, I will not give you this exact answer, and I don't know what is the exact answer. I will give you the related values. Right? So that's my predicted answers. And how do I got to this related answer? Because I have a lot of points available on the plot, and I understand that these points, if you tell me, I understand these things are maybe the related answers. So that's how it creates its own data map in its model, and it tries to give you the future. In future, if you ask any question related to that only, then only it is going to it can answer according to the previous dots that it is having. Right? That is why it is getting trained on a differences or patterns it sees in the data. But then only it is able to recognize the new point that you are asking. Okay? The new point we are calling them as training data. I mean testing data. When you are testing, at that time you are not going to tell your y. You are just going to tell the x value. Y is the outcome. So it has to give you the outcome. So in the last examples that we did practically, you might have seen some numbers we already had in y. And when we check in the answer, the values are definitely different. Okay, some of the values are near to that value, and some of the values are very far away from that. Okay, so those values are actually the nearby values of the existing point that you have given. It is trying to predict the value. It doesn't know the exact. All right, and it just done the one what you can say episode. It just running on one cycle. All right, so that's how. If you train them into 100 times, 1000 times, obviously it will give you very near answer, and maybe the fraction maybe will change. All right, that's how your model will get trained based on the data and the patterns that are there in the data. It may be the number data, it may be the textual data that are fine. During the chatting program also, they just keep record of all the answers that people have interacted or you have not trained. For high only there will be 100 responses, and they will just pick one of the answers from there, and just give it to you. And that will be the probable value that they will pick it. And the probable value will be the percentage of confidence value that they record, and based on that value they will be doing it. Okay. For hello, there might be 100 values. So based on the confidence values that they have recorded already previously, they will give that responses. All right. So that will be a training that is happening. In supervised, I am talking about present. Okay. Let's understand one thing first, how it is getting trained. Then we go back to other things. Just focus on supervised machine learning because it is easy to understand for us as well as to you. In terms of how people can learn and how can it is similar to your getting the training from teacher, and then appearing for the exam where only question paper is available, not answer. Answer you have to write it, and probably you might be predicting some answers and you will be writing, and the answers that we are expecting might be near to the actual answer that I am expecting. You might be writing 80% right answer. You will not write or you may not write 100% right answer. I will consider the question paper and the testing data, and I will consider your answer sheet as a predicted values. Alright. Now if I ask you, I have told you some topic and you told you have learned it. If I ask how did you learn it and how do you predicted those values, I mean how did you wrote those answers, you tell you I have heard 100%, I have remembered 90%, I have produced it 80%. Alright? So that data is definitely having a mismatch between the actual expectation and the actual prediction. Fine? And humans are different in learning, and models are using mathematical formulas and mathematical patterns of value changes to remember what are the answers and what I have to reply. They are nothing but mathematical models. We spell them machine learning models. They are actually mathematical models. That M is changed to machine, okay? Because we take help of machines which executes our instruction faster. But if I ask you, okay, machine will execute. Okay, how does machine understand that it has to learn? She only understands zeros and ones. From start we are learning this thing. So machine understands zeros and ones. So definitely somebody has to convey that. So as you're writing Python, so interpretation will happen for the program. So if program is there, definitely it has to execute. So what has to execute is the question. So we have given the algorithm as a program, and that programming is descriptive programming or dynamic programming. That means the program is not having its own values. Understand? Program is not having its own value to execute. If you do not give the data, for example, take out the data and tell the program to execute. It will not execute it up. Because it doesn't have the data to go forward. It needs the data, then it can go forward. That way, your program can only work when you have the values. And if I tell you the same situation in terms of mathematics, I have the formula, I tell you to calculate. Start calculating. You will stop. You ask me the next question. Give me the values so that I can put in the formula and I can give the answer. Okay? That way, your machine learning program are just the programs which has the mathematical equations in them. And it's not only one equation. There are multiple equations which are handling all your problem statements one by one. Alright? Your mathematical equations might not be solved in a single equation. It might need another equation to be the biggest outputter. It might have to be forwarded to the next equation. Next equation might give the output, and that has to be supplied to the next equation. The equation we are using, then we will be getting the answer. Alright? Similarly, our machine learning programs will expect the same. It has to have some formulas because we wanted to get the end output as expected. That's why your machine learning model or machine learning program is not a general program like how you write in Python. It is a mathematical model. So mathematical model understands how to manipulate the data and produce the output. You understand that? That is how machine learning programs will look like and they behave like. They are not like general programs that we write with a step-by-step process of executing the instructions. You understand that? That's how you have to imagine whenever we tell machine learning model. It's not machine learning model. You tell machine learning model, but think that it is a mathematical model, or mathematical equations underlying that. Those equations are actually hidden inside the algorithm that we are taking directly as a name. We tell linear regression. Okay, linear regression. We just took the name of that because sklearn is giving us the facility. I used it, but what is happening internally is there is a mathematical model being handled. And you have seen it earlier also in the initial phase of business and statistics. You have seen those small parts. Individually, you have focused on it, each side, and you have just calculated it. Now is the time to use those small components, what you have learned there, to apply it here and try to understand. Alright? It should not look new to you. That's what expectation is of mine. All right, I hope you understand that now. Machine learning model and how machine learning model is expecting the data to go forward and try to learn from the data patterns available. If you give less data, you cannot expect it to find a pattern. For example, I give 5 lines of Excel sheet data, and I ask the machine learning to learn from the data. It is not able to find the patterns in the data. So more the data you give, more the pattern it can find, and more accurately it can give the answer. Okay, scatter plot. If you give me 4 dots somewhere on the line, and if you tell me, okay, predict some value, the value might be somewhere where the dots are nothing is there around the dot. What should I predict? I will predict only whichever the nearest point is there from the distance. The scatter plot. Okay, one line is there, the linear relation, there are some points, 4 points, here. And I'll give 1 point near to the middle. So you will not be able to see what kind of values will be predicted here. Alright? Okay, that's how we just talked about training of the model. Got it now? How it is getting trained and how the model will look like, we will see in the next class. Right? Practically, we will create a model and we will export the model and we'll try to open that file and see what it is recording. Right? That will be the next. Okay, let's understand this. Model training is done and it has learned it and it has created its own understanding. Right? Now, how about model evaluation? How do you do evaluation? Evaluation is nothing but how efficient it is. The efficiency and the way it is giving us the output, is it mapping or matching our expectations or not? That is nothing but evaluation. If it is meeting our expected values, then it is actually getting trained and it is actually getting giving us the response as expected. If it is not, what deviation is happening? What kind of a deviation is happening? That will also be seen. And as I have told you, your machine learning model will learn from the data. Then you should become happy as well as sad both at the time. Reason is you have to feel happy because you are driving the programmer, you are driving the learning with your own control of data. You are controlling the data, that means you are controlling the learning. Happy? You should also worry about what if I give the wrong data and I am creating a practical application. For example, I am creating an application for detecting a disease and I have given the wrong data set. If those who don't have cancer, if you tell them there is a cancer, problem happens. Just think about it very seriously. If the person is not going to die, he may sometimes feel like it. Right? So data is very important when you choose the data to train it. Alright? That's why it is very serious thing when you try to train the model, you should be very much clear and very much sure about the data that is assigned is accurate and this is how I want to train my machine. And I want my machine to learn like this patterns. Alright? Obviously they will be given, most of them will be given in the photos itself in this image data. But still there might be some diabetes data and some of them we will train them with the image data and the picture data. So this I'm just talking about how you are controlling the model. You are controlling the model with the data that is assigned because it is just a syntax in the program. Program is just syntax. Algorithms. Complete control is from the data. That's why in data language we say 80% of the time, in terms of percentage, 80% of the project time. For example, you have been given 3 months. 80% of the time will be spending on preparing the data and making it ready for the algorithm to get trained. Okay, training and evaluation will take only 20% of the time. 80% of the time you have to make your preparations to the machine learning model to get trained. Alright, that's how seriousness is there in the data. Alright, let's go ahead. So you score the model in each iteration. You do each iteration and you see the improvement. If the improvement is happening, then you will continue. If improvement is not happening, for example, negativity, negative numbers are coming. Presently you got trained for 60%, again the score is becoming 50%. Then you stop that model. The training has to stop. So you have to write that script also. If the model number, the efficiency is not increasing, or if it is static, I will stop the program. I will give 2 chances for the program to do. In the second chance, I will terminate the program. So you have complete control over learning of the algorithm also. That you have to take care of when you design your own model.
Okay? Just to write one more new program.
New program for?
Because learning was the efficiency was only 20%. So we have to discard that program and write one more.
Stop that program. Stop the program and let the new algorithm come in and this how to stop. If it is 20%, if it is increasing, we give 2 chances. From 20 it might go 40. From 40 it might go 60. Then will not stop. And what 2 chances it increase. Based on data, because you understand the sampling of data. Some data is not at all useful. That's why it is not increasing its efficiency. Another sample data speed, which has given its own pattern and is increasing its efficiency of learning.
So every time you have to feed in the new data.
No. Data set is already available. It is taking some of them and is very clear. Data sample it is taking, and because at a time it cannot take whole data and write it.
Every time we have to do 10% of the data.
It will take accordingly whatever algorithm we have written. In the algorithm we will write it. Because in the algorithm we will be having an array, and that much array will be processed. Like how we have a 64-bit numbers we only take and 64-bit only will process. That will it takes it. Okay, let's go ahead. And once the model is evaluated and you understand that the model is accurately working, then you have to go with prediction. Okay, if you are designing a commercial application, you have to evaluate the algorithm along with the model with the accuracy of more than 95%. All right, you have to tell your users that its accuracy is more than 90, but it is not accurate, so that they can rely on the second check of the same or second verification. Like your BP monitor or sugar machine in your electronic machine is not accurate if I say. Then what do? You just check that as a temporary confirmation. What do? You take that number and you do minus 5 or plus 5 or minus 4 or plus. You do that. Okay. So due diligence will happen when you tell them a clue that I am 90% right. So 10% you take care of the plus and minus. Alright. So that will happen when you actually do model evaluation. You will understand that what to tell. Model evaluation is with that knowledge base. And once you go to a prediction, you will be able to understand that how my model is actually working in real conditions. Real condition means it doesn't know something and asking that question. So how it is using its previous knowledge of training, how it is answering my question. So that way it is going to give you the confirmation of whether the model got ready or not ready. If it is not ready, train them again and see if the percentage is very high. Then again you try to predict it. So this cycle has to continue. So the cycle will not stop here because they are not marked the next thing. It is the continuous process until and unless you verify that the model is perfectly working. And if it is perfectly working, now you can give it to the people who want to use that model. Alright? So this is about machine learning pipeline. So these processes will be one by one. So the first one is data collection and integration. Data collected act as an input to the model, and we are saying the inputs are called features, as we said. They are your X values. Data collected in this case are considered examples. Involves a lot of data. The collected data should answer the following questions: what is past customer history? What were the past orders for e-commerce or any of the e-commerce orders? Is the customer a prime member of our bookstore? if it is an Amazon kind of a store, does the customer own a Kindle? Kindle is an Amazon one of the a tab used to read, or it's a reader. Okay, it's a digital book or digital library for the readers for Amazon. Okay, all the questions. And one more question: has the customer made any previous complaints? So all these, why they are asking? Anybody? What is the past customer history? Do they have past orders? Is the customer is a prime member of the bookstore? Does the customer own the Kindle? Why they are asking these questions? What are the most important questions? Can you understand why they are asking these questions? To the data. Data collected in case of our considered example of Amazon, for example, it involves a lot of data. That data has to answer, the collected data should answer the following questions. The question is, why that data has to answer these questions? This is the first question. You understand? So they have taken a first step called problem. So they defined a problem. So let's understand that. Consider building an ML model for a company's customer care service. Consider company XYZ as an online bookshop. That XYZ is Amazon that delivers books and Kindle to its customer. That delivers books and Kindle as a tab to its customer as a business. And this company wants an improved customer care service. And it wants that if the customer calls helpline for any kind of issues, say for replacement of books, complaint of Kindle purchase or some other services, the company wants to ensure that the customer's call gets directed to the right service person in a minimum time, and that the process should be smooth. Okay, they wanted to make that process smooth and the complaints has to go to right person. This is their problem statement. To build a model for customer care service of a company, we will use ML pipeline for systematic development of a model, which will help them in redirecting a customer's calls to a right per service person in a minimum time. Alright. So this thing they wanted to do. So this is the problem they have defined it. And when they define the problem, immediately next thing is they have to look for what is the problem's key decision making points. Alright. Key decision making points they have to find out. So they are your KPIs. What is that?
Key performance indicator.
Key performance indicator they have to identify. That's why they are asking those questions to the data that they collected. Right? They have the data and they are asking those questions to identify what are the KPIs for the machine learning model. Okay, so the first step in the solving of the problem, they have taken the first step as data collection and integration. Okay, so we were here and we said that we wanted this data that is collected to answer all these questions. Whether the person has a customer history, I mean, what is the past history of the customer? Whether the past orders have been there for the customer? Is the customer a prime member of the bookstore, or does the customer have a own a Kindle? Has the customer made any previous complaints, and what are the most of the complaints are there? So they are looking for all these questions as their KPIs. All right. The more the data is, more better our model becomes, because more different complaints are there. It understands what will be the more number of complaints are coming on what date. Okay. One problem comes one time, and there are some 10 problems which are unique. What do you learn from that? Nothing. Okay. One problem, same problem is being told by 1,000 people. and one problem has been told by 100 people, one problem is told by 200 people. So which is the serious one? 1000 is the number, right? So that's what we are saying. More the data, more the better the model you can create. Once the data is collected, we need to integrate and prepare for the data. Integration of data means placing all the related data together, and many databases that you look for are actually not being stored in a single place. That is another scenario you might understand. This you will learn when you actually learn about data mining subjects or projects. What happens? There is a slicing happens or cloning happens. Okay, there is a database slicing happens. It will be vertical or it will be horizontal. Right? Vertical means you have a one table, like you have student table, for example. I'm taking small example. So when you have a student table, you will not store the whole table, I mean the whole headers and its all data. I will not store in one server or in one location. For example, in here I will not store the whole table. I will divide that table. Some of the headers and its own data is stored in B. Another half data is stored in Belgium. Another half data is stored in somewhere. So when you collect all those parts and at one place you join whole table. At one place you form the whole table. Alright, that is one thing. And another method is part of the data of one region, like Hubli people's data of, for example, Instagram, I will store it in Bangalore. Hyderabad people's data I will store it in Chennai. Okay, that way I will divide them. For example, if in USA there is head office, they wanted to analyze the India's data. So what they have to do? They have to do this thing, integration they have to do. They have to collect all the data centers from Chennai, they have to take, Bangalore they have to take, all the sources they have to take, and then they have to build one dashboard of whole India. This is how it is happening. Get it? So that is the integration is in one way of dividing the data in multiple places and then integrating. That's one. And another possibility, if you go to your companies, is they might be maintaining their data in multiple clouds or multiple cloud databases. From there, they might be pulling. Alright, there's two possibilities are there. One thing is only one company, same database, only one database is there. They have divided the data in multiple places. One scenario. Another scenario is one company is maintaining the different data in different clouds and they are trying to integrate it. Alright, so that way you can integrate that data so that you can keep that data ready for the next phase to come in. Because we want the data ready for the machine learning. We can't ask for the data later. Once I have the data ready with me, I can feel that I can make that data ready for my machine learning model. And I can also decide what data I can use. Alright, that's why we're saying data collection and integration of data. You understand now what is integration? Collection of data sources. Okay. In interviews, it is very important question when you go for data analyst job. Data analyst job, because your role contains the data. So definitely you have to answer these questions. If I have the data in USA, one of the source, and one of the source is here, and some of the Excel sheets I have in my Apple computer. How do you use them? How do you analyze them and train your model? How do you, what technologies you use it, or what tools you have learned to make this process very easy for me or my company? You have to know those names of the tools. You should collect all the sources and link them and try to give you the dashboard. Fine? Have you heard of any tools? Such tools? We'll discuss that those tools later. I'll tell you those. Have you? One? Then?
Yes.
Yeah, one. Everyone. Any other cloud providers are giving such facility? Have you? And you are giving? iCloud is giving that. iCloud is giving what tools? Storage data. Cloud storage. No, it's a visualization method. No, that's again not the visualization. Tableau is one of them which uses that. I mean, let's not distract. So I'll get to that later. It's already discussed that thing. So I just wanted to let you know that integration will happen from multiple sources and you just gather them at a place. The data preparation phase starts in which manually and critically explore the data. The data preparation phase tells the developer that that is the data match expectations. Is there enough information to make the accurate predictions or not? And is the data is consistent? You understand both the keywords? It's very important. When you say, is it enough data for the prediction? Why they are telling that? Because they wanted to have sufficient data so that a model can prepare its own prediction or patterns in the data. So that data must be that much sufficient. So how much sufficient is dependent on the data and its what you can say variation in the data. Alright, obviously the data must be large enough to train the model. Okay, how much large? You will not be able to predict it. Alright, you will be able to only understand when the model gets evaluated. Okay, is the data consistent? What does that mean? The data has to be consistent in whatever it is promising at the heading. It is telling something, so it has to be consistent in that specific features you have calculated in the columns and rows. So that will be your data collection and integration is the first phase. So in this phase itself, you will have lot of jobs. I just searching before you come into the class. Yeah. So there are a lot of jobs itself in the only one phase. Have you just seen how many phases and how many things you just now discussed in the data itself? So in that only you get a one job which you can do for whole of your job, whole of your day. Only this thing you can do. Right? They are not explaining both things. They just told data collection you do. And here is the visualization that you are going to do. And before that, in data itself, you have to clean the data, you have to make the data filling, or you have to replace the data, or you have to remove the data. All those data preparation activities you have to do as a data cleansing role. In the data cleansing role, you will be able to work on the one phase of the whole project's machine learning project. Okay, in the 7 steps, you have learned these many things in AI course. You are only going to work in a company on this. Okay, so you are going to decide. You have to decide at the end of the course. I have learned these many things, but I am good at this thing. I am interested also, and I am good at this thing, and I understand how to do it. And I will only do that thing. Only decide only that thing and learn only that thing perfectly. Perfectly for interview, as well as to work there. To work there, you have some time for training as well as interview. For interview, you have to be so confident. And I know this much, only this much I will do perfectly. That's what is one of the places where data cleansing will happen. I am very much interested in data collection and pulling the data from the APIs. I understand how data will come and what format the data will come. And I will be able to manage that data. I will put that data and put them in Excel sheet. All those activities I am very much interested. Let's go for database. You have a lot of roles. In that team you will be. Now you want to allow the team, and in that team you will be one of the part. And you will be doing all those things. Okay? And they will not be standing behind you and telling you to do that. They will give you the freedom of your time and you can do it. Alright, so that's how these one phase will give you a lot of different roles as well as responsibilities when you actually join the work. Alright, okay. The next thing we have is exploratory data analysis and visualization. Once the data is prepared, developer needs to visualize. So who is the developer? The person who understands how to program this algorithm. So that person is my developer to understand that criticality of the data that you are preparing. Once the data is prepared, developer need to visualize the data to have better understanding of relationships between the data set or within the data set, how each of the columns are related to each other, or whether each of the columns are not all related to each other. They have to just check. That is my exploration on the data set first. Alright, you understand that? What are they trying to say? They are just checking whether my first column is related to, or what is the relationship between my first column and second column. How about my first column and third column, first column and fourth column, first column and fifth column? What is the relationship between them? Are they related anyway? Are they second column and third column related anyway? That will be checked in the exploration and visualization. And why so? Because they can become one of the key parameters for decision making. Here I can tell you to my machine learning model that these are my critical columns that you have to use in these phases, in this phase. Alright. So that way I will be able to create an exploratory visualization for creating a relationship between multiple parameters. Now I'll ask you the question. I have two columns. In that two column numbers are there. Now the question is, what algorithm you will use to analyze the relationship between, or to find out the relationship between the two columns? What algorithm will you use? Yes, exactly. You go for linear regression because you have two columns and you are just trying to check what is the relationship between both the columns. Alright? If they are related, then they will form a line where you actually draw the regression line. And if they are not related, they will randomly scatter in all the places. Okay? And becoming outliers. That means there is no relationship between them, so you can check in another column. One column is keeping constant x value. Why are you just expecting the other column? I have taken 1 and 2. I take the 1 and 3. And I just check one set. Okay? And even wherever I have, if I am only interested in the numerical values, which wherever there is a text values are there, I will try to convert them into numerical values. Then analyze them in terms of the numerical values. That way, exploration, visualization, exploration, trying to find out the relationship between them. Visualization will help me to visualize whether relationship exists or not. Directly I cannot see its data, how can I see? So visualization will help me to see. Alright, visualization tools. So next question is, do you know any visualization tool in Python which I can use in data visualization? Is the question of interview. We were asked, what is the question? Answer. Matplotlib. Okay, so Matplotlib is a bigger package we have. So what plot will you use to analyze linear regression? What is the name of the plot that we will use to plot linear regression? Okay. So what kind of graphs will you use to analyze this kind of data? To find out the multiple values relationship. Scatter graph is the right answer. So you need to understand what kind of a data where I can visualize. This is another type of intelligence that you should have. Everybody has learned the same thing, but you should know what kind of data where I can visualize. This is another thing that I'm giving you to prepare for the interview. All right. Okay. So when we get to see, we can notice that the unseen patterns that we may not have noticed in the first place when we just collected the data. Now, if as I'm visually looking at it, I can understand how the data is. Take back to data people that they are not giving me the right data. Please, this kind of data is missing because this kind of data is not at all there. So please check that thing and give back to me again. And again, I will do the same. My team will again get back thing, and in visualization phase, again we will do the same thing. We check the relationship between multiple things. And again, I will check if these things are confirmed. Confirmation is there. Confirmation is there. We say the next thing, next phase. Else I will again be working with the data people. So this team will be working with the above people and the below people. The previous phase and the next phase. Okay. I hope you are not new to these keywords. Data visualization can be done by plotting. Histograms is one of them. Scatter plot is another one, and many other plots that you have learned can be used for different data that you are going to use. After visualization is done, data analyzed so that developer can decide what ML technique he may use. Very important. Okay, just try to understand what they are saying. After I have understood how the data is there, so now I am ready. So now a developer has to analyze so that developer can decide what ML technique or ML algorithm he may use to analyze such kind of a data. All right. This is very important phase. What technique you have to use. Now the question is for everybody, how do I decide my algorithm? There are a lot of algorithms are there. How should I decide? You have to decide based on what kind of problem that you have. Do you have classification problem? Do you have segregation problem? Or do you have do you have the problem where the data doesn't exist at all? Do you have a problem where data exists as well as zeros exist, but I want to solve this kind of problem? So what kind of problem you want to solve? You want to solve the regression kind of problem, you want to solve classification problem, or you want to solve reinforcement kind of problem. So you have to decide what kind of problem you have, what kind of data you have ready with. Then you can decide, I have these many options. I have 10 algorithms ready with me. So in 10 also, they will do classification only, all 10 will do classification. But some of them will do classification on numerical data. Some of them will do on image classification, some of them do on video classification, video frame classification. So I will do shortlist these many 4 or 5. So in them also I will shortlist. These 2 I feel are comfortable for this kind of data. So only these 2 I will check now. I will check both of them. Whichever is going to be good, I will be going to decide. So my data is going to help me to decide data and the problem that I am solving. Type of problem I am solving and type of data I have will help me to decide my algorithm. For example, I have 1 lakh images of some fruits or some animals. I will use some other algorithm which is comfortable to read my images, convert them into matrix, and TensorFlow algorithms are very easy to do that. I will choose TensorFlow algorithms to do my photo analysis tasks. I will not look for other algorithms which are there. I will definitely not look for them. So I will be deciding problem, data. Second, decided. This is very critical thing. This is where experience of senior engineers will come into picture. Junior engineer or fresher will not decide. If I tell them to decide, they just keep blank, obviously, because they don't understand. Because they don't have experience of using different algorithms. Alright. So that's why senior developers will come into picture who is having at least 3 to 4 years of experience. And they will be drawing more salary than more 5 to 6 times salary than you, because they understand that criticality. See how critical it is. You don't know just little thing, and they understand that little thing. Small difference, but the small difference will come only over a time of period. You understand that? Sometimes you definitely become a senior data analyst. That time you understand what is criticality of that. Okay. Anyways, so criticality of choosing the ML algorithm is very critical with respect to the performance of your algorithm. That is, and performance analysis you have to know. You should know with the help of algorithm analysis techniques. Have you learned anybody? Algorithm analysis techniques.
You are learning how efficient it was.
Yeah, you are trying those graphs to check how efficient it is. So that is nothing but performance grading or performance analysis. How about if I tell you there are techniques which will analyze the time space complexity. Have you heard of them? Time space complexity algorithm.
How much, so is within how much time it's able to complete the task? That's
Yes.
yes. How much memory it's consuming? That's
During the execution process, temporarily, not only permanently, temporarily, how much memory will be displayed. So that will be your time space complexity of any algorithm that you have to analyze. Some people will be there, so that there will definitely there will be team who is only doing that thing for whole of their jobs. All right. So that might be the questions in your aptitude tests when you go to interviews. Definitely, this one part. I'm just giving you the hint what you need to do for again. If you don't know, let me know. That's the next step. So space and time complexity of algorithms. This is the keyword I'm giving you in Google search. So that will be one of the another factor which you can't see here. That will also affect your decision making of algorithms. You have to have a chart of algorithms, time space complexity. Algorithm name, time space complexity. You'll be just checking on different patterns. We just see on internet just the algorithm names, we don't see all those things. But you have to prepare, or the company will give you the list of algorithms and their properties. They will give you the Excel sheet. Take this. You decide. I have given all the numbers to you. You decide. Now you should know how that Excel sheet will be read and what should I decide. Then only I will able to decide that. Alright. So that is very critical place where senior people will suggest you and you have to follow them accordingly. In the concept example case of unsupervised learning may be used to analyze customer purchasing. If it is customer purchasing habits, if you are looking at, then it is unsupervised learning. So you don't have data, so you're just analyzing based on the purchasing that you are doing. Alright. So that will be exploratory data analysis and visualization phase in the machine learning model design.
So, yesterday in the game, data was not there, and by playing the game, it was nothing. So, it was able to play 100 games in 1 day, or say 10 minutes. And the data was generated for 100 games.
Right.
Okay. So, so here in that real-time case of having the data from the customer, we have to wait until they come and purchase and finish their shopping. So, model has to wait till they are the data providers.
Obviously.
So, their data collection will be very slow in real time.
Obviously, the data collection is slow. So you have to have multiple dashboards. So you have the previous history of, for example, newly the shop has opened, the supermarket has opened. For them, nothing is there. They have to start from zero. So for them, it is ideal. That shop which is already available since 5 years, for example, Reliance Jio, Smart Store is there from 5 years in that space. Definitely, there are a lot of customers they have, a lot of connections they are done. They have the data. And you can use the supervised learning. You already have the data. So your decision will change now. When you have the data in the newly stored, newly open store. That way you can adopt. Definitely, as I told you, they might already have the dashboards which we don't know. If you look at their, if you know somebody who is a manager in some store, they will tell you that thing secret. That we have the dashboard to analyze yesterday's sales and stock of the today. How arrangement has to be done before 10 o'clock when you open the store. What arrangement inside we do when the shutter is off. What inside we do. So those activities you will not know. That is use it later.
So if you are hiring the manager from that company, it's like hiring the model from that.
For that, they understand that and they will do that. Because manager may change, but dashboards is already maintaining the database of previous employee, previous customers who visit that store. So new employees also, new manager also, just looking at the old data, you understand which kind of customers will come here and what kind of ticket size they have. One customer will come, 300 rupees. Another customer will come 200 rupees. Another customer 500 rupees. So they understand that average customer or average earning of this supermarket is one customer will have average of 4 to 500 rupees of.
So model is the manager which being in the environment learns about the behavior of the customer.
Behavior of the data. Behavior in the data. Pattern in the data. Sorry, pattern in the data.
So if the manager moves to other company or model moves to other program, so it will other place, it will carry the experience or learning. So it can apply from the
supermarket.
So it can apply from the data.
It has to go empty-handed because the supermarket is different. CSP is different. Customers are different. The customer is different.
So it can carry what is the learnings.
Learning it can happen only when the case is generic. When the case is generic, then it can carry its old experience of generic case and it can apply to next case.
So its experience is nothing but young man seeing in the equations.
Independent features you need to extract and keeping with that thing as an experience. Any new point will come, which will tell you what is point.
And looking at the customer also, you will be able to predict how much you want to
Purchase. So with that whole data, like I'm talking about only one day, or 1 month. And we having exactly what month he is going to give. If you have to have 1 year's data of each month, we exactly get to know how much we will earn in this month, this month, this month. With that data, I will be understanding that in what month I can keep offers and in what month I will not keep offers. Alright? That way, my data will decide when the offer has to be there and when it should not be there. If market is on and it is running smoothly, I will not keep offers. I only keep offers very in a very weak place where my business is not happening. I can put the offers and by make my graph increase. Obviously, the whole year's target has to complete. In middle, I just have to look at the previous year's data. So my KPIs I have defined there. KPIs I have defined. My key decision points I am designing, and based on that I am going to analyze my data. And you cannot design an algorithm. And everybody has to understand each project of machine learning will be unique in its own way. Every next project will be unique. You cannot say that this project and this project are same. My previous project and this project are same. No, it is not possible. Every project that you may do here, you may do in a project, final project, you may do a company. Every ML project, AI project will be different. That's why you have to understand, you have to go through the process that you have defined, and that process will give you the new outcome or new algorithm or new model every time. Alright, because problem is different, areas are different, your data is different, definitely you are choosing the different algorithms, or maybe the same algorithm, different outcomes because of the data. That will happen all the time. Alright, that's why ML engineers and most of the engineers who work on the data will be given more importance only when they understand the criticalities of the data and the algorithms that they are going to consume. Algorithms which consume the data. When they understand this combination, then that person has to be hired because you understand the very critical point of the whole process. You understand what data this algorithm will consume and what outcome will be given. And that person also understands very critical points of this algorithms. How algorithm behave based on the data that person will accurately understand. At least 2 to 3 algorithms when you understand very accurately, then you are master of that whole space. You give them anything and they crack it. They crack the data. That's how it has to be. That's how you have to get ready for the machine learning jobs. That's why, okay, the next thing, feature selection and engineering. Feature selection and engineering. I will remove that clock because everybody is having the clause. Okay, that clause is for me actually. Another clause. Okay, 2 minutes. Feature selection and engineering. Here we need to look for the features as I explained. Feature selection means selecting what features the developer wants. What features the developer wants. So what is he talking about? He is talking about what are my key elements on which I am able to tell my algorithm that these are my important points. So that I am going to decide. That you should tell to your developer. To use within the model, features should be selected so that minimum correlation. What is this?
Some dependency between the columns should exist.
Must exist. Okay, correlation must exist between them, and maximum correlation exists between a selected features. For example, when you take an Excel sheet, for example, you have 10 columns. In that, 6 columns are having exactly very important relationship between each other. 6 columns. 4 columns are having a very lightweight relationship in terms of their own columns. So that way, if you don't have much relationship between the columns, but they must exist a relationship between the columns. Then only they can be in the data set. That's what we are trying to say here, that there must be a minimum correlation between the data set. I mean the data columns that exist, and the maximum correlation exists between the selected features and the output that you are expecting. Feature engineering is a process to manipulate the original data into new and potential data. All right. So what are we trying to do? It is a process to manipulate the original data into a new and potential data. You have taken the collected data, but that data is not at all feasible or ready for the machine learning model. So you manipulate that data so that can be useful and is very potential data for decision making for the algorithm. That way, you just have to manipulate that data according to your need, not the collected data's format. That's why I told you, if I have the male and female column, I mean gender column, I'll just change that column into 0 and 1, or any number I'll change that. That is easy for me to manipulate. That is easy for me to analyze in my algorithm. That's why I manipulated that column. To manipulate the original data, and it has a new potential. I mean, new and potential data that has a lot many features within it. In simple words, feature engineering is converting the raw data into useful data that are getting the maximum out of the original data that we have collected. Okay, feature engineering is converting the raw data into useful data to get the maximum out of it. Feature engineering is arguably the most crucial and time-consuming step of ML pipeline. Obviously, as I told you, obviously, so you have to spend more and more time on this one. As I'm about to give you an assignment, after you learn this thing, you have to spend a lot of time on understanding your own problem and what data it needs to solve that problem. Small model you might design, but to design that small model, you have to spend a lot of time on understanding the features of your problem. And you do that with the other methods we have. So arguably the most crucial and time-consuming step is ML pipeline is feature engineering. You have to do it. Feature selection and engineering answers questions like are these features going to make any sense in our predictions or any meaning in our predictions? These features will participate in making my prediction easy or not. So those kind of features I have to find out. I have to pick them. So picking those things are crucial, and also it is a time consuming in terms of finding out accuracy in terms of your relationship between data, and as well as how you are going to manipulate the data to make it compatible with the algorithm. Alright, that will give you the clarity about accuracy and your precision about the data. Alright, this is about your phase of feature selection and engineering. Alright, and in this one only there are lot of designations that will be taken. The designation that you see on internet is just some part of those designations. Many small roles will get it into this. If you are good at only this much, you will have a job ready. If you are only good at only visualization, only I know Matplotlib, I don't know any other thing. But I know accurately Matplotlib, I can visualize any data. You tell me data, I give you the accurate model. And I visualize it and give you the insight of what that model looks like. You have a job ready. Okay? That's how it is easy. Just you need to understand the whole thing initially. Okay. So what we are learning is the whole thing, but we need to understand all the phases of it. It does not mean that you are in the role and you will not be promoted to the neighborhood and you will not be working on these things. You will be working on it, but you need to understand all of them. Alright, you can just. So the fourth step and all the steps we will have it in next class. And I want all of you to go through these 7 steps and read about them and come back to discuss more interesting facts about this. Soon after this thing, we'll go and immerse ourselves into creating those models. Fine? So that we can at least be ready for creating our own models. Alright? We stop here today. Thank you for joining today.